Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is Cambridge Physics 5054 course, and I'm your teacher, Mariam Rafique. Today, we're gonna discuss chapter number 19, and the name of the chapter is DC circuits or direct current circuits. So before getting into the core concepts of this chapter, I would like to share some learning objectives. For example, to know what a potential divider is, to derive and know how to use the potential divider equation, to know that the load affects the output of a potential divider, and in the last, to know the applications of potential dividers to detect temperature or light levels. The question is that what is potential divider? A potential divider, by definition, consists of two or more resistors connected in series with each other and a source of fixed potential difference. So students, in electronics, a voltage divider, or also known as a potential divider, is a passive linear circuit that produces an output voltage that is a fraction of its input voltage. So voltage division is the result of distributing the input voltage among the components of the divider. And a simple example of a voltage divider is two resistors connected in series with the input voltage applied across the resistor pair and the output voltage emerging from the connection between them. We can also draw a circuit diagram for this arrangement. So this is the circuit diagram. What is the potential difference across each resistor? We can use potential difference between points A and B as a supply for another component. You can see that R1 is consist of 50 ohms and R2 is consist of 100 ohms. They both are attached in series or arranged in series. And we want to find the potential difference from point A to point B. To supply a fixed potential difference between any value between 0 and the source potential difference. This is the first use of a potential divider in a circuit. To supply a variable potential difference from a fixed one, and to supply a potential difference that varies with physical changes, for example, position, temperature, or light travel, or light level. Here is another example. You can see the arrangement of the circuit R1 and R2. V1 across R1 are the voltages and V2 are the voltages across R2. Now we have to see the supplying a fixed potential difference. The total resistance of the circuit is, R1 plus R2. And the current through the resistors is equal to V0 divided by R1 plus R2. As we know that V1 is equal to IR1, and now can be written as V1 is equal to V0 times R1 over R1 plus R2, and V2 is equal to IR2. That can also be written as V2 is equal to V0 times R2 over R1 plus R2. Now deriving potential divider equation. For an unloaded potential divider, the current is the same through both resistors. So we can say that V1 over V2 is equal to IR1 over IR2. So the voltage is proportional to the resistance, as we can see here that V1 over V2 is equal to R1 over R2. Now we have to see the potential divider equation. Few points we have to keep in our minds, that if R1 is greater than R2, then V1 is more or less the supply voltage. And if R1, the value of R1 is less than the value of R2, then V1 is close to zero voltage. So V0 as an input to the potential divider and V1 as an output, the circuit itself provides a way to tap off a voltage between 0 voltage and V0. Confused? So what's the difference between a variable resistor and a potential divider then? When a variable resistor is used, the total resistance of the circuit is being altered. Also, the potential difference is not being taken across the variable resistor. Now, using potential dividers, we have to see that it can be used as a volume, brightness, or contrast control, making and designing a circuit to use as a temperature sensor, making and designing a circuit to use as a light sensor, and controlling logic devices. These are some common applications of potential divider. Now there are some effects of different resistive loads. Output voltage is affected by load resistance. Connecting a resistor across the output reduces the output voltage. Shorting out across a bulb reduces the total resistance of the bulb, and the wire is in parallel with the bulb. Now there are some questions. For example, a series circuit is connected as shown in the diagram in the very start of the lecture. So what is the potential difference between A and B? An additional resistor of 100 watt is connected between the 50 watts resistor and the cells. So what is the potential difference between A and B now? And the additional 100 watt resistor is now connected in the parallel with the first 100 watts resistor. So what is the potential difference between A and B now? Also, how do we get a variable supply voltage from a fixed one? And how can we measure physical changes in position, temperature, or light level, etc.? So these are the answers. A potential divider is one way of producing a variable potential difference. And a combination of a suitable sensor, you can say angle, position sensor, thermistors, or LDR. You will come to know about these terms, thermistors and LDRs, in the next chapter, inshallah. And a potential divider enables measurement, monitoring, and control of physical changes. The potential divider equation can be derived by rearranging the ratios above to give, like V output. If you find out the V output, that would be equal to R1 divided by R1 plus R2 multiply by the input voltages. So resistor voltage dividers are commonly used to create a reference voltage or to reduce the magnitude of a voltage so it can be measured, and may also be used as signal at low frequencies. Students, for direct current and relatively low frequencies, a voltage divider may be sufficiently accurate if made only of resistors, and where the frequency response over a wide range is required, such as an oscilloscope, probe, and a voltage divider may have capacitive elements added to compensate load capacitance. So in electric power transmission, a capacitive voltage divider is used to measure or for the measurement of high voltages. So thank you so much and good luck.